All right, welcome to Module 4, Investigation 8. We are going to talk about something called logarithms. Have you guys heard of logarithms before? Some yes. Anybody know? Brand new? Okay. All right. Okay, similar to your pre-class assignment from last night, maybe even easier. What number, if I ask you to solve for x, what number would x be? Sure, x has to equal 3 because 2 to the third power equals 8. What would x be here? 6, because 2 to the 6th power equals 64. What would x be here? -1. Why? Because 2 to the negative first power is really 1 over 2 to the first power. In other words, 1/2. Negative exponents cause fractions. So we're okay with those, right? What would x be here? We know it's bigger than 3, right? Because 2 cubed is 8. And we know it's less than 4 because 2 to the 4th power is 16. But how would you get that exact decimal? At this point, you might not have a good answer unless you know about logarithms. Okay? So what is the need for logarithms? Well, we need to be able to solve something like this. Previously in your math career, if you didn't have logarithms, you could not solve a problem like this. They asked you to do it in your either homework or pre-class, and how did they suggest you do it? Do you remember how they suggested you do it? They asked you to graph it. Okay, so if you graph it, if you graph y equals 2 to the x, you could figure out when the output is approximately 10. Yeah, was it the pre-class? They asked you to do that? Yeah. One of them, something we have done recently, it told you to graph. It might have been even the day before. I don't remember. Okay, so if you graph y equals 2 to the x power, the graph of that looks something like this. And then you would need to figure out, where am I getting an output of 10? Okay, so if this is your 10, you'd have to figure out what is the input there. At this point, that would be the only way we would know how to do it. But now we're going to learn how to solve this. So when we solve equations, we're always using inverse operations, right? If I have x plus 5 equals something, I have to subtract 5 on both sides. If I have 2x, I have to divide by 2. So what we need is an inverse operation to a variable in the exponent, and that is logarithms. So here's how we will define a logarithm. For x greater than 0 and b greater than 0, with b not equal to 1. Okay, so that's your precursor information that you need. Y equals log. Log is, of course, short for logarithm. Base b of x is equivalent to b to the y power equals x. So what this is saying is you can take any equation of this form, b to the y equals x, and rewrite it in this form. You need to have that pretty much memorized. Okay, here's how I always think about it. Let me do some different colors here. That's exactly it, and that's what I'm going to show you right here. Okay, so if you compare the two different forms, notice what's the same. The base of your logarithm, and it is subscript. Okay, so log x and y, those are all on your normal writing line. The b is subscript, so it's lower. So the base of your logarithm is the same as the base of the exponent. Then the other two things, I always think of it like this, they switch places. So you gotta like cross them. So the base is still the base, the other two things switch places. Remember how when we learned about inverse functions, we talked about switching the x and the y? These two functions are inverses. A logarithm is the inverse to an exponential equation. So how do you solve an exponential equation? You use its inverse, which is logarithms. Now pay attention to what your stipulations are. Your x, what you're taking the log of, right here, has to be greater than 0. It cannot be negative. Your base has to be greater than 0. And it cannot equal 1. What would happen if your base was 1? Think about it right here. 1 to any power is just going to be what? 1. So you wouldn't actually have an exponential equation. So that's why b cannot be 1. Why does x have to be greater than 0? Could you ever have an exponential number, like just this part, nothing else happening? So just maybe 2 to some power. Could you ever get that to equal a negative any number? No, there's no way to do that if b is greater than 0. If it were negative 2, you could do it, right? But b has to be greater than 0, so that can't work. Okay? All right, so we need to first practice rewriting going from one form to another. So I have this equation, and I need to figure out how to write it in logarithmic form. So I'm not being asked to solve yet, I am just rewriting. Log base of equals x. Yeah, don't actually solve, just rewrite it. Don't solve it yet. But you're right, x would be 3. Okay, so, and notice how I'm saying it. It's log base, whatever the number is that's subscript, of whatever the regular number is, and then equals whatever it equals. So your next one would be log base of equals x. And then your third one, base, you gotta say it right, log base 2 of equals x. So if I see something written like this, what is that actually asking me? It is saying 4 to what power equals 64. It's saying exactly what that says. So if I need to solve this, that's what I need to figure out. 4 to what power is 64, and I would get x equals 3, like Noah said. What? Are you talking about like when we were talking about it over here? Because this would be your input number, and that would be your output. But then when we're working over here, it's just a variable. It doesn't matter. Like we're not thinking about like graphing necessarily. All right, hold on. Let's do number 2. So on number 2, This notation is simply saying 5 to what power is 1 over 125? Well, I immediately know it has to be a negative, right? Because a negative exponent is going to make it the fraction. And then it would have to be what number? 3. Because 5 to the negative third is 1 over 125. Now the second one, yeah, they're asking you 2 to what power is negative 32? You can't do it. Why can't you do it? Because we said over here, whatever you're taking the log of has to be positive, and what we're taking the log of is not positive. So this is not possible. Try it. So speaking of calculators, pull your calculators out. In these calculators, the log button is on the right next to the 1. You got to hit Control 10x. Everybody see it? And then you can type the base number in, and then type in what you're taking it of, and it will tell you it's a non-real calculation. It's not possible, undefined, something like that would be fine. All right, let's go and do some more here. Actually, why don't you guys do these in your group? So just rewrite them. Try these 4 before we go on. I'm going to pause the video. If you're watching the video, go ahead and try these 4 before you keep playing the video. So the first one would be log base of equals, okay? The second one, what's the base of the log? 5. What are you taking the log of? And it's got to equal a, but what about that 1.5? Yep, right here. For that second one. That's actually not what you want to do. In order to change it into logarithmic form, you got to do something first. You need to get it into the form a to the x equals b. Yeah, so you got to divide by 1.5 first. So b over 1.5 equals 5 to the a. Sorry about that. I knew that didn't feel right. That's why I looked it up. So it would actually be log base 5, but it's of what? B over 1.5 equals a. Now go ahead and do that other one. Yeah. So the third one is log base 2 of m equals 4t. So that's already set up. That's in the form. Yeah, that is totally fine. No, if you were actually trying to solve for t, yes, but we don't need to do that. We're just rewriting. Okay, so on this last one, then what's the first thing you need to do? Sure, divide by 3. So you would get log base of equals 2k. Everybody okay with that? All right, so without a calculator, let's see if we can figure these problems out. So in order to do this first problem, it's probably going to be beneficial to change it, since we're not using a calculator, into exponential form. So what is the base of my exponent? What's the exponent? And I'm equal to 4. So what must y equal to? So certainly we could have stuck that in the calculator. That would have been easy enough. But you can also do logs, if they're nice, simple numbers, with some mental math. Second one, base is 9. 9 to the equals 1 over 81. Yes, no. Negative 2. Negative brings it to the bottom. 9 squared is 81. Third one, what would it be? 3 to the equals negative 2. Can't do it. Why not? Okay, what you're taking the logarithm of is not allowed to be negative. Why? Because there's no way I can take this number to any power and turn it into a negative. And then the last one would be, good, 5 to the s equals 10. And we would not be able to do that precisely with mental math, right? But we know it has to be between what? It has to be between 1 and 2. Is it going to be closer to 1 or closer to 2? Okay, so I don't know. I'm totally just guessing maybe 1.3-ish. Oh, man, it was close. Approximately 1.3, and when you actually calculate it, it's closer to 1.4. Are we okay with those? Excellent. Here's a graph of y equals log of x. So this is what it looks like. Notice that your x values cannot be what? Cannot be 0. Okay, so that is a huge stipulation for logarithms. Okay? No. Radicals. Yes, that is correct. Okay, common logs and natural logs are special cases of logarithms. Common logarithms have base 10. Natural logarithms have base e, which is why we learned about e yesterday. That's where it fits in here. Common logarithms and natural logarithms are the most common logarithms, hence the name common. And natural is one that occurs when we are dealing with exponential growth and decay, which occur naturally, so that's why that one's called natural. Back in the day, calculators and lesser calculators, if you have a scientific calculator, they cannot do any logs except for these two. So if you just pick up a regular scientific calculator like this one, it will have a log button. And when I press log, not that you can see it, but when I press log, it just shows up log. There's no space to put a base in. All it gives me is the space to put the number I'm putting in. Okay? There's also a button that says ln. ln is natural log. So it has its own abbreviation. Again, we know that a natural log has a base e. So what I'm saying is that log base e of x is equivalent to ln of x. Okay? And if you see a log written without a base, like this, that actually means the base is 10. Because those come up so often, they have their own special notation. Notation without a base, and then ln. But if you're using an old calculator or a less advanced calculator, you will only be able to do common logs and natural logs. Our calculator is really nice, that yellow one, that it can do any base. So back in the day, we had tables of values. They didn't even have calculators, and you had to convert everything into a common logarithm. So the way you would do that is something called change of base formula. And I am only telling you this in case you are doing homework and you don't have a calculator that can do these. So if you are asked to find log base, what's that last problem we did? Log base 5 of 10. So that's one we could not do in our heads because we don't know 5 to what power is 10. Normally on your yellow calculator, you can just type that in. If you're on a lesser calculator, what you have to do is change this into log base 10. So that's why I'm not rating it, right? Because I don't have to rate base 10s of 10 over log base 10 of 5. These two things are equivalent. So the change of base formula actually says if I have log base A of B, it is equivalent to log base X of B divided by log base x of a. And you can choose to make those x's anything you want. So it would make sense that we want to make common logarithms since we know calculators can do common logarithms. You shouldn't need this in this class when you're in here because you have the yellow calculator. But again, this is just for if you're working outside of here and can't do the logarithm. Okay? All right. Before we look at that, so you will see problems that have LNs. So if I was doing, you probably can't even see that. Let me make it way bigger. If I was doing this first one here, ln of e to the 7th. ln of e to the 7th. Well, I know ln is really just log base what? E of e to the 7th. So think about if I were to convert on this, can put it into exponential form. I'd have e as my base. My exponent would be unknown, right? Because I'm solving what is this equal to, call it x, equals what? So what would the x have to be? What would be your answer? 7. So anytime you see natural log of e to some number, it's always just going to be x. It's always just going to be that number. It'd just be 10. So this one, you could rewrite as the natural log of e to the what power? Negative first power. So what would be your answer? Negative 1. Is that making sense without going through all of them? Okay. Which letter are you looking at? Yeah, negative 5. Negative 17. Square root of 2. Negative 10. Square root of 3. Are we okay with all those? Okay, anything else I want to talk about here? No, I think you should be able to do all of those. This is just more of the same thing we've been doing. And then more of the same thing here. Okay, I feel okay. Do you guys feel all right? Okay, so tonight you have a homework assignment. You do not have a pre-class. No. So here's what's going on. Keep in mind, remember, I will not be here the next 2 days. So here's what's happening over the next 2 days. I get to go to a math conference. I'm so excited. Sandusky. It's actually at Kalahari. Yeah. So excited. No, I'm going to do math all day. Last time I went, Mr. Hot went, but he won't be here this time. Huh? What do you mean weird math people? No, there's weird people everywhere. All right, so on Thursday, you are going to do the second half of Module 4 Investigation 8. That's why you don't have a pre-class. You will have homework again on that, and you will have, so maybe that'll be homework number 2 on that. It's really number 24, I guess. I should put that. Then you will have a pre-class, which will be covering Module 4 Investigation 9. On Friday, oh wait, so that's, wait a minute, did I write that right? Yeah, so on Thursday, we're going to finish Module 4 Investigation 8. You're going to watch a video of me instructing you on the rest of this section. You're going to have homework and then a pre-class. On Friday, you're going to watch a video of me instructing you on Module 4 Investigation 9. You will have a homework assignment, which will be homework number 25, over Module 4 Investigation 9. You will not have a pre-class because that is the last section in the unit, in the module. You will also have a quiz on Friday. That quiz will cover your compound interest problems, both formulas, the ones where you're compounding continuously and the ones where you are compounding any other way, and maybe the first half of Investigation 8, so what we've covered today. Okay, not what we're doing Thursday and not what we're doing Friday. It's Mr. Jim Batista. Yeah. Like fuel. So, I'm looking at on Monday, we'll probably just like make sure you guys are all good with everything that you've done while I've been gone. Maybe Tuesday, a review day, and then Wednesday will be the test. Everybody good? Any questions? Okay, have at your homework then.